Hi guys, hope you had a great weekend. Nice Easter. Um, this is your video for Monday, April 13th. And I wanted to start moving along with our chapter 15, processes of evolution discussion. So I've been giving you PowerPoints as we've gone through this, and I'm going to update your PowerPoint again because it'll include the 4 new slides that I'm going to go over today. So let me back up just a little. Okay. Yeah, that's it. And just remind you that we've been going through the processes that lead to evolutionary change. And so I am not going to go through all those again, but remember there's 5 different things that can happen within a population of organisms for evolutionary change to happen. And even in the secular videos, you'll hear professors refer to these types of changes as microevolutionary changes, or changes that kind of can lead to new species or like varieties within a species. And the thinking is that over time they'll add up to producing whole new kinds of organisms. But again, they're mutation, selection, gene flow, genetic drift, and non-random mating. Now, so we went through each of those and talked about how if those types of things are happening within a population, then we would say that evolutionary change is happening because changes in allele frequency happen. So that brings us back to the idea that your evolution lab was hitting on, and that is that evolution can be measured by changes in allele frequency. And as you guys put in your, as an answer to one of the questions in your evolution lab, allele frequency can be calculated when you take the number of copies of a specific allele in a population and divide it by the total number of all the alleles within a population. And if that changes in a population over time, then we would say that evolution is happening. So we can say that evolution can be measured by changes in allele frequency. And one model that calculates allele frequencies or looks at the allele frequencies within a population is called the Hardy-Weinberg equilibrium model, or the Hardy-Weinberg equation. And this is a model that's where scientists are assuming that the allele frequencies within a population are not changing over time. In other words, they're assuming that evolution is not occurring. So this model is only applicable in a population. We say that Hardy-Weinberg equilibrium is only met if evolution is not occurring. And so it's basically a way of calculating the frequencies of different alleles within a population and then saying, okay, these allele frequencies are going to stay the same as long as evolution doesn't happen. So for evolution to not happen, for the for a population to be what we call at Hardy-Weinberg equilibrium, then the following conditions have to be met. So there has to be no mutation, no selection, no gene flow, a large population size, and random mating. And you'll notice that these conditions correspond inversely to the 5 principal processes of evolution that I just reminded you of. I told you that for evolution to happen, you have to have mutation. So if you're going to meet Hardy-Weinberg equilibrium and have no evolution, then you have to have no mutation. Selection is a way that evolution can happen. So you have to have no selection if you're going to meet Hardy-Weinberg equilibrium, and so on. Now, I have a number of videos that I am going to ask you to watch from Khan Academy and Mr. Anderson from Bozeman that explain Hardy-Weinberg because it's math, like some algebra, and it's better for them to explain it because they can write out the equations. They write out the equations as they explain it. And I've gone through all these videos, and I think they do a really great job. So I'm going to have you watch videos to learn how to calculate Hardy-Weinberg equilibrium. And they also help explain to you why it is a nice model to use, even though we know that populations in nature never meet the conditions of Hardy-Weinberg equilibrium. All biological populations tend to evolve. Now, I don't mean macroevolution, of course. I mean they all evolve according to the principles of microevolution. There's always mutation happening at a low rate. There is selective pressure. Organisms don't mate randomly necessarily. Pollen can float in from a different place. Well, I guess that is random, but when we talk about sexual selection, that's not random. Like, why do the female birds prefer the willow birds with the super long tail? That's not random, that's sexual selection, and so on. So what the videos will bring out is how this model is useful for predicting the approximate genotype frequencies of a population. And I think it's Mr. Anderson's video that helps you see that that's actually really useful, because if you know the allele frequency for a certain allele in the population, then you could predict like how many people within your populations might be a carrier for a certain genetic disorder, things like that. And also, when we look at how populations deviate from Hardy-Weinberg equilibrium over time, you can, that helps you like identify which type of evolutionary change is happening, which process or processes of evolutionary change cause that type of a shift in the Hardy-Weinberg equilibrium. So it helps scientists to know kind of like how, like exactly like not just that a population is evolving, but like what is at work to make it evolve. Okay, so what I'm saying might be a little confusing. I hope not. I'm just trying to introduce you to this concept, and then I want you to watch several videos between now and the end of the day on Wednesday that go through these Hardy-Weinberg principles. Beyond that, this week I'm not assigning anything else because I know you need to finish Darwin. Chapter 13 is due Tuesday, like at 11:30 p.m. and Chapter 14 is due Friday, and we'll have our last graded discussion on Darwin. So I'm not assigning anything else for you guys to do, and I hope that's clear on the RenWeb LMS, but if it's not, you can let me know. I think that's all. So it was good talking to y'all. This is Friday when I'm filming, no, Thursday when I'm filming, and it was nice talking with y'all today at our graded discussion. Miss seeing you, and I hope you have a good weekend, and I will probably, I don't know when I'll have another video, maybe like Thursday, but just get in touch with me if you need me before then, and I'll be praying for you guys. Bye-bye.